Thank you, Julian. I'm happy to talk about our experiences here today. I think it's been a great project, and I hope we'll present some of the highlights to you today in this seminar. First, I thought I'd mention a few things about American commercial lines and the industry and our business. To outsiders, like I was before coming here, it's largely an unknown industry. We run a manufacturing company that manufactures barges and towboats that operate on the inland waterways. And the larger portion of our business is actually shipping commodities in those barges on behalf of our customers. We operate on the Mississippi River, the Illinois River, the Ohio River, and around the Gulf. Just to put things in perspective, that image there on this slide is about 40 barges. It's 8 barges across and 5 barges deep. It's all pushed by one towboat in the back that has a crew of 8 to 10 folks. The total area covered by that footprint of barges is almost 6 acres, and it's the equivalent in terms of shipping capacity of around 2,400 semi-trucks or about 600 rail cars. So our operations really run at scale for our customers. A little bit of the background for our technical environment before considering moving forward with our AWS migration. We were recently new customers on EBS 12.1.3. We completed an implementation in February of 2013, covering core financials, AR, AP, purchasing, inventory, and an asset management module. It's a mission-critical application for us, as it is for most businesses. Many of our users are at our headquarters location in Jeffersonville, Indiana, but we do have users at other facilities, and we've actually sampled users on those towboats that you saw in that picture as well around the asset management application. We integrate our EBS environment, and in particular its data, with various other things at ACL, including a BI environment, and both of those are protected with single sign-on. Our project spanned 2 years of our initial 3-year hosting engagement with a third-party host provider. So by the time we went live, we were almost ready to start shopping a new hosting solution. What made us consider Amazon for that solution was probably the same kinds of things that many of you are considering today. You want a platform that's flexible. You want to be able to pay as you go for your infrastructure services. And perhaps, like us, you want to limit your on-premises investment in a data center. They're expensive. They can be somewhat inflexible. And we saw Amazon as key to improvements in all these areas. The ability, in particular, from my position, to grow or shrink your infrastructure footprint with truly a few clicks is really impressive. Our environment is always changing. So it was a difficult exercise in the beginning of this for us to determine how large our servers needed to be, how do we need to manage our database instances, and committing to AWS and that as a platform gave us the ability to make those choices in a not permanent way, or a way that could be easily changed going forward. Our journey to AWS began with sort of a recognition that we couldn't do it on our own. We did have some staff competency around Amazon, new to the American Commercial Lines team. That was an intentional hiring choice. And we had begun dabbling a little bit with Amazon in some small ways, some Linux server environments, Route 53 DNS. We had looked at S3 storage for backups and things. But really, we knew the expertise required to successfully run an Oracle instance on Amazon is specialized. In many ways, it mimics running Oracle internally. You are building server environments and you're configuring storage, but the way you do it in Amazon is different enough from the way you do it in an on-premises data center that we definitely recognized we wanted to go outside for an Amazon partner. What we found interesting about Apps Associates is that they were both an Amazon partner and an Oracle partner. So they have expertise in both configuring Amazon infrastructure and services and monitoring it and managing it, but also in deploying Oracle solutions to those. They manage our EBS environment for us, as well as the AWS platform on which it runs, and those two things together are important. Our project was laid out in probably a typical way for a project like this. You plan out a time frame for migrating your development and your test and your production environments. We had a lot of time luxury here. The hosting company we moved from was flexible with our departure, and they supported this migration for us. That too was important. We set up a development environment. Once we were comfortable with the development environment, we replicated those processes to our test environment. And ultimately, when we obtained enough testing and sign-off from our business partners, we migrated our production environment over a weekend. Really, our actual operational downtime was consolidated to about a 4-hour window. For us, that included exporting the data, copying it over from our past host provider to Amazon, and getting up and running. That's pretty quick. I think a lot of people probably have concerns about how do you get large volumes of data into Amazon. For us and our available downtime window, it worked with no special outside steps. There are other options, and perhaps they'll be addressed later in this seminar in the Q&A that follows. Over the production weekend, one of the probably trickiest pieces of this entire architecture for us to get right was the single sign-on integration. Really, that's just complexity in the Oracle world, but Apps Associates supported us, and we quickly hammered those out within an hour of completing that migration. So we were up and ready well in advance of our Monday morning workers showing up. And with that, I'll turn the call over to Abdul, and he can talk more about the solutions architecture provided, and there you go.
Thank you, Mike. It's really awesome to hear directly from a customer the experience of migrating to AWS. And hello, everyone. I'll give you an overview of different components, especially involved in running an EBS, Oracle EBS, or any specific enterprise workload on AWS. Just like what Mike did, a lot of enterprise customers, according to Gartner, are skipping the getting their feet wet, try things out, DR or dev environments, and skipping all that and directly jumping immediately with their production loads into AWS. According to Gartner, again, increasingly organizations are looking into, what are the things that cannot move into the cloud rather than looking into what should move into the cloud. If you look into AWS infrastructure, there are many things that are very different from a conventional IT landscape. One of the key concepts is the geographic flexibility and geographic distribution of our services and infrastructure components that are available. This makes it possible to build very fault-tolerant architectures, as well as take care of the data sovereignty issues based on which country you are in, and keep your infrastructure very close to where it is being used. AWS components, infrastructures, and services are available in 11 regions across the world, and each region is divided into multiple availability zones. Each availability zone is in a different floodplain and earthquake zones, and most probably serviced by different electrical providers and networking providers, just keeping as isolated from each other as possible so that there is very little dependency. So even if one availability zone goes down, it doesn't affect the other availability zone. This allows you to build really fault-tolerant architectures so that now you are not just concerned about just an instance going down. You can actually build architectures that will even take care of an entire availability zone or an entire region going down. It also allows you to build your production environment or your production infrastructure in one region where your business is running, and build your dev infrastructure in a different region where your development teams are. So in cases where there are teams in India or Philippines where you have outsourced your development work to a third-party company, or you have your own development teams available in any of these places, this allows you to have development environments closer to where your development team is, and still keeping your production environment very close to where your business is. Now, all these availability zones and regions are all connected with very high bandwidth, a world-class low jitter network, allowing you to replicate data and move data across as you need. One key component of AWS infrastructure is the ability to isolate your infrastructure components in your own software-defined network. We call it VPC, or Virtual Private Cloud. It's very important for the isolation level and security of your workloads, as well as making sure you can replicate the same kind of environment as you had on-premise when you moved to AWS. A VPC allows you to bring in your existing IP addresses so that when you're migrating an existing workload that's configured in a particular way, when you come over to AWS, you don't even have to change your IP addresses. We also have what we call AWS Direct Connect available to connect your network, your enterprise private network, directly to AWS to have a secure, high-speed, low-latency connection between AWS and your on-prem network. For any enterprise, governance and security are very, very important. AWS provides you multiple ways to secure your network, secure your workloads, as well as govern these workloads, audit them, and keep track of what is happening in your networks. They have fine-grained access controls that you can apply to your EC2 instances or your network VPC or subnets using multiple levels of policies at ACLs, at resource groups, and also we have in-depth audit controls using CloudTrail, where every one of the API calls that is made from your account is logged for future audit and any action that you want to take on. Most of the AWS services that are available, especially the core components, are all certified for all these myriads of certificates that you see there. So you can run your workloads in HIPAA compliant environments and FISMA compliant environments. We are FedRAMP compliant. Many of our services, especially most of our core services like EC2, EPS, S3, many of the second tier services, they're all compliant with all the certifications that you see on the screen, allowing you to run many different kinds of workloads on AWS. Now for many customers, when they bring on environments to AWS, it normally happens at an environment at a time, just like in the case of ACL. ACL migrate Oracle eBusiness Suite to AWS. There might still be other environments like PeopleSoft or Hyperion or some other data warehousing environments which are still running on-prem that hasn't been migrated to AWS yet. For many of these businesses, it's important to be able to integrate back to the workloads that are still running on AWS, that are still running on-prem, which is very much possible using some of the things that I mentioned before. If you are running on VPC or you have Direct Connect, you can connect your on-prem network to AWS. So AWS becomes part of your network. That's your integrations that you have already done with other applications on-prem still working fine as they used to work before. A key component of AWS infrastructure is EC2, or Elastic Compute Cloud. It is equivalent to a virtual server. You can bring up and down any of these EC2 instances as you need, and you can scale up and out any of these instances as you need as well. This is very important when you have workloads that are spiky depending on what kind of workloads that you're using. You take Oracle eBusiness Suite as an example. The amount of work that eBusiness Suite does on the second week of a month is normally different from the amount of workload that you have on it at the month-end closing or the quarter closing. So being able to horizontally scale allows you to bring in more application servers and web servers as you need to take up that additional load. Based on how your business grows, it also allows you to vertically scale by switching from your existing instances to a larger instance as you need. There are many, many different types of EC2 instances available to run the different kinds of workloads that you have. There's some instances are suited more for web server kind of workloads, while others are suited more for database kind of workloads. It's important that when you pick your EC2 instance, look at the kind of workload and match the corresponding kind of EC2 instance that you need for that workload. These EC2 instances also vary on the amount of memory and the CPU cores available. The CPU cores could be important based on the kind of license that you are using for the workload that you're running. For example, if you take the EBS or e-business suite as an example, the application itself is based normally on user plus licensing. So you have licensed the application for a specific number of users, but the database is usually licensed for a particular number of cores. So when you're picking the EC2 instance, you need for the database load, you want to make sure you choose the right EC2 instance with the number of cores that you have licensed for the database. The other core component of AWS is storage. There are various different kinds of storage available, starting with the local storage in the EC2 instance itself. Then we have simple storage, or S3, with very, very high scalability and durability. And then Glacier for archival, which is a long-term cold storage, which is kind of equivalent to the old tape-based storage that most of the enterprises use on time. One other key component is the elastic block storage, which is a block storage similar to SAN that enterprises normally use for database workloads, database storage, and file servers. Elastic block storage can be made available from 1 GB to 1 TB in size. If you need more than 1 TB, you can stripe multiple EBS volumes together to come up with a larger volume. Each volume can go up to 3,000 IOPS. So if you have needs for larger IOPS, you can, again, striping multiple volumes together makes available larger IOPS for your workloads. And when it comes specifically to Oracle workloads, I'm talking perspective Oracle database, e-business suite, PeopleSoft, any of the Oracle workloads. Running it on AWS really simplifies the implementation. It actually makes everything easy, from creating images of your environments to cloning and to doing updates and patching. And that way, your implementation costs and the timeline could be reduced tremendously. Many cases we see 50 to 70% reduction in the implementation time. Mike actually spoke about how long it took ACL to migrate the environment over and migrate all the data over. We have seen the similar story with many of our customers either migrating their existing workloads on AWS or implementing brand new Oracle workloads on AWS. Some of the Oracle products our customers use on AWS include the database and the database tools that come with it, Golden Gate or DataGuard, Oracle e-business suite, PeopleSoft, JD Edwards, and Siebel. In the middle tier, Fusion Middleware, SOA Suite, WebLogic, and the whole suite, including OBIE, Hyperion, and ATG Web Commerce. When it comes to licensing, all Oracle licenses are fully portable to AWS. This includes enterprise license agreements, or ELAs, which could be unlimited licenses or BPO licenses. It also includes Oracle Partner Networking licenses. If you are migrating an enterprise application like e-business suite, you're probably bringing user plus based licenses, which is number of seats for that particular application. you can just bring it as it is to AWS. If you have a license for 500 users, those 500 users license is valid on AWS as well. When you're bringing core-based licenses, especially for applications like Oracle Database or WebLogic, the core-based licensing works very similar to the core-based licensing for any Intel platform or Intel bare metal servers. So Oracle uses a core multiplier of 0.25 for standard licenses and a core multiplier of 0.5 for enterprise licenses. What it means is if you are bringing an enterprise Oracle database to AWS, and for example, let's say you have an 8-socket license, then you can run that particular database on AWS up to a 16 virtual core instance. Now let's switch over to Thiru Sadagopan from Apps Associates to look more into how exactly the implementation was done for ACL. Over to you, Thiru.
Thank you, Abdul. So let me now describe how exactly we helped migrate the Oracle eBusiness Suite solution for American commercial lines onto the Amazon Web Services platform, and talk you through the various operational considerations for any organization that is considering such workload. So I'm going to look at the various aspects of migrating Oracle ERP, Oracle eBusiness Suite to AWS across these following areas: network access connectivity considerations, the various instance types, machine images, and operating system level considerations for your Oracle eBusiness Suite platform. Storage, which is often a very important consideration for virtualized platforms as to how we would configure, what are some of the best practices that you would consider specifically on the Amazon Web Services platform, and so on and so forth through the security aspects, some of the controls that are available to meet compliance requirements. And eBusiness Suite is a specific business application that has a unique maintenance, housekeeping functions. How would you look at some of those? And also look at how are you going to be able to migrate your application stack to AWS, and look at an approach that you would consider, some timelines to consider. So network connectivity. As Abdul talked about earlier, Amazon Virtual Private Cloud, Apps Associates consider is an absolute necessity, absolute best practice you should consider for bringing your eBusiness Suite workload to AWS. It's a private network segment that is accessible only through the network connectivity that you would define as an organization, or Apps Associates would as your systems integrator. It allows you to define even a public subnet zone if you are deploying modules such as iSupply or iSupport that many of you are familiar with. There are public-facing modules within the Oracle ERP system. Quite often, we do not expose the Oracle stack directly. Reverse proxy is often a best practice to have a DMZ facing the public, which in turn communicates with the internal server. Amazon Web Services also provides several network constructs. Security groups is a very important one. Very simple and easy to configure, but it also has a good level of control that it gives you in terms of putting a fabric around your groups of servers, application tiers, database tiers, defining whitelist of IP addresses or other security groups, so that you're now able to control who has access to your specific eBusiness Suite applications and database stack environments. In terms of connectivity itself, we find that often an IPsec tunnel works just fine, both in terms of performance as well as to meet several of the internal controls and security requirements. Certain organizations have also chosen to use a direct connect if that meets their long-term directions and strategies in terms of adopting the AWS platform. Now, looking at instance types, AMI here, shown on the slide, stands for Amazon Machine Image. This is one of the first fundamental blocks of being able to move any kind of Oracle applications or any kind of a workload over to Amazon Web Services. What is the operating system we're going to use? 64-bit, 32-bit, is it Red Hat? Is it going to be Oracle Enterprise Linux? These are the kinds of considerations you're looking at. Now, as Abdul pointed out earlier, there is a direct mapping of physical cores to the AWS cores in terms of Oracle licensing. So if you're running an 8-core database server, we could choose an instance type on Amazon Web Services that is 8 cores and appropriate memory configurations, which could be identical or sometimes superior platform for running your database workload. Care to be chosen that you're actually choosing an Oracle provided or a Red Hat provided Amazon machine image that is available for consumption. Typically, we would start with one of those, apply necessary RPMs and whatnot, kernel updates to meet the prerequisites for your Oracle workload, very similar to what you would do internally in your own private cloud or physical environments. There are specific considerations for 32-bit versions you should be aware of. If you're not running the Oracle Release 12 version of the business suite, if you're running version 11i, as we all know that 11i version of Oracle ERP does not support 64-bit for the application stack on Linux platform. So that would pose some challenges in terms of configuring the business suite stack on AWS, but there are certainly ways to conquer it, but the memory limitations and the process limitations would be something that you definitely should focus on. There are also some considerations around para virtualization and the HVM virtualization stacks that you should be aware of in terms of the size of the Amazon instance types that you would require. We'll certainly be happy to provide you more details in terms of what would be the ideal instance type that you would choose. But these are some of the best practices you certainly will want to consider for instance types in AMI. Now, when it comes to the database tier itself or the application tier itself, although Oracle ERP supports different operating systems or different versions of the operating systems themselves for between the database and application stack, many of the DBAs and apps DBAs in the world know that it's good practice to have the same version of the OS. So what it boils down to in the Amazon Web Services world is to essentially prepare a base AMI of the version of Linux that you choose and update it with all the maintenance packs or the RPMs and whatnot that you require, and use that as your base image to launch your production, test, develop, and QA kind of environment that you would require. That's what you would choose in this case, is to kind of use the same base AMI for both the database platform and the applications platform. Now, for database tier, we could have several options and configurations based on the instance types. One of the questions that come up often is to be wanting to be able to run a clustered database configuration on the AWS platform as well. There are certainly options here in terms of if availability from a hardware failure is a primary concern, with Amazon Web Services being a cloud-based platform with the ability to launch instances within seconds. Quite often we're able to achieve very high levels of recoverability in terms of what the platform itself has to offer, and that some of the customers have chosen not to deploy a rack-based solution just purely for highly available considerations alone. Certainly for other kinds of considerations for workload balancing and things like that, we can look at some options that are meaningful and suitable for the different SLAs and requirements that you may have for your database tier. For the applications tier, once again, the same principles could apply. If there are instance types that map to what you require for your load, we could certainly do that. But if your deployment architecture requires multiple application servers and load balancing, those are absolutely possible, and leveraging Elastic Load Balancer, you're actually able to deploy multiple application tiers and run your AWS workload, run your Oracle applications workload here. Single application file system, shared application file system to reduce patching and the overhead of maintaining multiple copies of your binaries are certainly overcome here as well by using one copy of the application system shared across all the application tiers. Custom file systems or NFS are definitely options that you can look at in terms of being able to use behind your Elastic Load Balancer. Now, storage, as I pointed out earlier, is a very important consideration. What I'm showing here is essentially a map of looking at the various storage options that Amazon Web Services has to offer, which is shown in the column on the left-hand side across instance stores and EBS with PIOps, pardon me, EBS with PIOps or SSD devices down to S3 and Glacier, and then looking at the different kinds of workloads that you might consider across the columns there for general purpose usage, database-specific usage, applications, and also looking at speed and durability of these various kinds of storage options that AWS provides. As you can see, Instance Store has got very little impact or usage directly within the Oracle application stack. There are some use cases there. We could leverage the temporary files, especially with some startup bootstrap options. We could definitely leverage instance stores for temporary files as required. But we find that we're actually able to use EBS, Elastic Block Storage, as Abdul described earlier in his overview, with specific consideration for provisioned IOPS, which is a term, PIOPS, that is used to indicate a functionality that AWS has wherein you can provision a specific IOPS that you require, anywhere from 500 IOPS up to 4,000 IOPS that you can specify for a specific volume, which then gives you a guarantee that 99% or more of the time that you have the specific IO available to your Elastic Block Storage. So those are obviously good choices for certain kinds of files like database and that require kind of low latency connectivity directly between your database tier and your storage tier. Some characteristics of durability are also mentioned here. S3 and Glacier are typically the destinations for your backup sets, and I'll talk a little bit more about some of the options associated with those. Now, taking the same storage discussion a little bit deeper to specifically look at Oracle database files and different kinds of file types, we're showing some recommendations for what would be the Amazon Web Services storage types that would be good fits here. Looking at the Oracle database file structure, such as the actual binaries themselves, the RDBS home, data files, read log, archive logs, and locations for backups. These are some recommendations as to how you would mix and match the different kinds of AWS storage types. You would see that EBS volumes and EBS volumes with specific IOPS provision are going to play a significant part for majority of the active database files that you're going to be configuring here. And PIOPS is going to be very, very important consideration. Another feature I would like to call out also is ASM, or Automated Storage Management, which is essentially an inherent database feature in the Oracle database stack, which actually allows you to better manage multiple EBS volumes. If your database size is such, or if your database performance requirements are such that you wouldn't use just one single EBS volume, but you would look at multiple EBS volumes, leveraging database feature ASM to manage those EBS volumes and then be able to deploy your database files across them will give you great benefits both in ease of management and also in changes you need to make to add or remove volumes to meet with your performance requirements and database growth capabilities. Moving on to the next slide, this gives you a representation of how you would then lay out for a sample database. What we're showing here in the bottom left is 4 EBS volumes with some sort of a striping on top, operating system-wise or ASM related. Here we're showing 4 EBS volumes, at each volume provision of 4,000 IOPS each is now capable of giving you 16,000 IOPS for your database performance. This is quite powerful and far superior to a lot of the enterprise class storage devices that are commonly found in different data centers here. Now, similarly for log destination, transaction log destinations, you look at another cluster of EBS volumes striped together with, say, lesser PIOPS. But it's just a sample representation. For dev and test, you could work with a similar function, similar feature, but you would provision with lesser IOPS. Because there is a cost associated with the amount of PIOPS that you would provision for your storage volumes, it makes sense to judiciously mix and match to make sure that you're meeting what your application requires, but not over provisioning or over configuring the required IOPS for your environment. This example illustrates how Oracle Secure Backup could be used. It's essentially a function of Oracle RMAN, which is the database backup utility of choice at most organizations, by specifically leveraging the Oracle Secure Backup plugin that's available, which directly integrates your backup, RMAN backup, to Amazon S3. You're able to send the backups directly to S3, which is one of the highly durable storage options available in the cloud industry today. Based on your lifecycle policies, you can also move some of your older backups to Amazon Glacier for better cost scenarios and cost options here. I'd like to talk specifically about what a couple of ways you could address your backup requirements for the Oracle Business Suite, specifically a database, specifically an Oracle database. Taking the same example here of a database which has got production volumes and EBS volumes, we can now look at RMAN, as we talked about, whether you want to use the OSB module and directly send the backups to S3, or you can have the RMAN function configured to send the backup to a separate destination for a file system. This is again another EBS volume with PIOps or without PIOps as is required for your performance requirements, a separate file system that you could send your backups to, which can then be snapshotted, which will go to S3. Snapshotting a e-business volume is a powerful functionality that is available within the AWS storage options, which allows you to take a snapshot of your environment, very similar to what you would see in storage snapshot capabilities in many storage volumes in the industry today. Another option would be, as I described earlier, to use the OSB module with RMAN and directly send it to S3 bucket. So these are some of the two different ways, quite effective, that you can be combined with what you require to meet your RPO and RPO objectives of your database backups. We're also configuring your snapshots to be periodically synchronized across region, from US East to US West, for example. We could also satisfy some geographical disaster recovery requirements for your Oracle e-business platform. But there is also additional configurations and more options available to have a live DR, and that's the subject of another conversation. Let's take a look at security specifically. The number one question that we often get when talking to organizations that are interested in adopting AWS in general, or specifically looking at mission-critical ERP solutions such as the Oracle e-business suite, is the cloud secure? How would I work with, how would I meet my internal controls? What are the different options that we could leverage to address these questions? So, as Abdul pointed out, there are various compliances. AWS has essentially built the infrastructure in alignment with various controls that are shown here, like SOC 2, FISMA, HIPAA, PHI, etc., etc. But however, what I want to indicate is that this is a shared responsibility. Configuring, maintaining, and making sure that your environment, your architecture in AWS meets industry compliance requirements that you require for your workload is a joint responsibility. Amazon Web Services, as I show here, is responsible for the various operations across the global infrastructure as well as the foundation services. Right? It is up to you as the organization or an integrator such as Apps Associates in terms of how best to configure the various aspects of the AWS functionalities and features, starting with the virtual private cloud, starting with the network and the security groups, right? Starting with the configuration of the ACOs and various aspects of this, consciously and in alignment, understanding best practices to see how best to configure it, leveraging best practices so that we are now in compliance and we are meeting some of the industry standards and best practices for running workloads such as these on any data center platform, whether it is a cloud-based platform or internal data centers. Now, Amazon gives you several capabilities in terms of meeting these various security requirements, whether it is segregation of controls, multi-factor authentication, or various encryption technologies for data at rest or data in motion as it's commonly seen in the industry, the network activities that Abdul and I have discussed at different times in this presentation, as well as tools for auditability and visibility into what has actually happened and how the environment is being maintained. So by leveraging the correct options and configuring it the best way in combination with what AWS brings to the table with certifications and compliances across various technologies such as this, you're actually able to build your AWS platform to meet some of these controls and requirements that are required. Now, Apps Associates as a service provider, as a service integrator, brings our own independent capabilities such as SOC 1 that helps organizations in combination with AWS capabilities to build totally compliant platform that you can then work with your internal control team to meet your industry compliances. Let's take a look at some of the housekeeping functions that are something that an apps DBA will breathe in and day out, and a business requires for applications such as the Oracle E-Business Suite, right? So cloning. Several organizations are quite familiar with this. If not a weekly occurrence, this is an occurrence at least once a month, or often more than that. In fact, American commercial lines required a process by which it would like to have a copy of the production environment cloned on a much frequent basis, daily or by, once in 2 days at the minimum. So we are able to leverage some inherent capabilities in the AWS platform, mainly the snapshots at the EBS level, elastic block storage level, to make your cloning process much simple by scripting, configuring, and using AWS Cloud Formation, which is essentially a programmatic interface by which you can launch and control various AWS services. You're actually able to do automated cloning for your requirements and for your various e-business suite administrative requirements here. Now, looking at monitoring, many organizations would already have some kind of enterprise-level monitoring tool, whether it is internally deployed or being administered from a cloud-based monitoring system. You're able to extend those monitoring capabilities into the AWS platform just as easily. CloudWatch metrics are also available for building additional metrics as required for the e-business suite platform. So let me look at now that I have covered some of the various architectural or foundational considerations that are required to build an e-business suite. Now let's look at how would you migrate, how would you move your Oracle e-business suite that is running either internally or if it is running in a third-party data center over to the Amazon Web Services platform. We'll be kind of showing an approach here, starting with reviewing, understanding the infrastructure, mapping it to and designing an appropriate architecture and platform on AWS, right? Looking at and understanding the security requirements, internal controls, and making sure that design architecture has incorporated necessary controls to meet those objectives. You will then go ahead and provision and build the AWS infrastructure. Whether you are a first-time user of AWS or you already have AWS infrastructure you're using for other workloads, we would build what is necessary, often a separate VPC if it's required, and build that environment. And we take a three-pass approach, similar to what we did at American Commercial Lines. The first pass being your first clone migration of your production environment over to AWS to build your first dev environment. Do some basic testing, test your backup infrastructure performance, backup and recovery process by doing restore testing, various activities like that, making sure that you have documentation correct. Repeat again as a second pass and consider this your UAT migration phase and have it opened up for larger user testing and validation, and eventually, based on the results of your testing, make your adjustments and go into production. As Mike McGrath pointed out earlier, we were able to do this in a very short time frame for the actual production cutover itself for the production migration. There are techniques that we can leverage with the database, just a few hundred gigabytes or multiple terabytes, in terms of how you would coordinate that synchronizations activities of your database system from on-premise or a third-party data center to AWS, so that we can look at reducing your downtime dramatically within just a few hours or even less than an hour, as the case might be. But however, I should also point out that using this as a change event and the regression testing and the other aspects that is going to go in this kind of a project, it also provides you the opportunity to do some enhancements to your environment, whether it is a database upgrade or an operating system upgrade that you're considering, migrating from 32-bit platform to 64-bit platform, or even across platform. We have a few organizations that are running in non-Linux platforms, obviously required to run on the x86 capabilities for AWS platform, uses as an opportunity to do those platform migrations. We have been able to help organizations do this actual cutover in as little as a 6 to 8 week time frame ACL, I know Mike McGrath explained earlier, they took a 3-month window to do this based on some specific testing considerations and some other changes they would like to that they were looking to make to their platform. So I just kind of wanted to summarize that this is an effective way to move this and migrate this activity further. This is a sample AWS infrastructure that shows how you could potentially operate and connect to a e-business platform in AWS. Looking at the corporate network on the bottom, connecting via VPN tunnel, it shows connectivity established to 2 regions, US East and US West. This is to accommodate a DR, a disaster recovery scenario as well. So if US East is your primary data center, you have provisioning a private subnet where production test dev could be running with some specific functions for monitoring and others that are running in the public subnet. And using a DR zone on the US West location, and then either looking at Oracle Data Guard function or a snapshot replication function to be able to get your data transferred or synchronized over to the DR zone, meet your RTO objectives. So with this overview, I'm going to invite Mike McGrath to join us again and talk a little bit about his experiences post-migration. Now that they've been operating their Oracle Business Suite on the Amazon Web Services platform, what has been the success stories and what are the future plans? Mike.
Thank you, Thiru. I will say that one of the major motivations anyone considers moving to the cloud is the perception of lower infrastructure costs, and in our experience, I would stand by the fact that that's been true. Not dramatically lower. Certainly we're achieving a cost savings here, and not insignificant either, but more importantly, again, the things that I mentioned earlier in the call, I think really drive home the flexibility of AWS. You pay for the services as you need them. You can choose whether or not to long-term commit. And that flexibility combined with the overall lower infrastructure costs, I think it's just very hard to achieve in any form of an on-premises data center. Post-project observations, I'd also say one of the things I like about AWS is the costs are very easily tracked on AWS invoices. If you're in any kind of environment in which IT services are charged back, the AWS billing structure really provides an easy path to be able to charge back services. On premises, it can be difficult to come up with numbers for what does a virtualization farm cost, what does your storage cost, but the AWS invoicing can really support chargebacks like that should you have them. The uptime, we have had no issues. In fact, just that connectivity is very similar to the reliability we got from our dedicated hosting provider before, and frankly similar to what we see in an on-premises system when when we've had those for Oracle environments or other environments and still do. There have not been any unique to AWS instances where we've had downtime, so that's been really nice. Over the course of the project and having lived with it now for 1.5 years, some of the other things that have been interesting, the AWS model, Thiru touched on a little bit of these features around disaster recovery. Your backup and recovery options are just different. So it's an opportunity to kind of reassess what you're doing for disaster recovery with your EBS environments because of the nature of just the flexibility and the rapidity with which you can stand up AWS instances. It gives you opportunity to do things differently should you choose to select a different path. One other thing you mentioned regarding our project execution, we did spend about 3 months going from building the dev environment to rolling out production. Certainly it could be done faster. One of the things that made that a 3-month project for us is that we were also applying a fairly large number of patches to our environment. So in addition to the migration, we had significant patching going on at the time. So our testing cycle, really it was longer because of the patching cycle. The infrastructure changes only can be executed really quickly. One other thing to keep in mind as you move more of your business services over to cloud-based environments, that connection path to Amazon. You learned earlier in the call from Abdul the kinds of options that you have with just the virtual private cloud connectivity or a direct path connection to Amazon. We are still just using a VPC setup. We are evaluating direct path options, direct connect options. But fundamentally, as you consume more bandwidth, you'll maybe want to reassess the incoming pipes you have into your facility and your own on-premises data center and network. We have not seen any issues there, but again, we do keep an eye on it. Future plans, we are happy with the AWS and the Apps Associates management of our instances. So as we look to the future, some other EBS-specific things we'll consider. Our identity management, Oracle Access Manager infrastructure lives on premises for us. There are some architectural reasons and even just a staffing and support reason that we will likely move that environment over to AWS, and Apps Associates will help us do that. For now, today at ACL, we keep our BI services internal. They're in our data center. They include much more than just the data coming from EBS. So right now, I don't see us moving that, but in the future, when data is coming from other sources outside of our data center today, it's likely that our Oracle BI solution would be a good candidate to move to AWS as well. And fundamentally, I just don't necessarily see a time when AWS would be, or ACL would be investing heavily in hardware resources for our on-premises data center. AWS is always probably going to be top of the list or first consideration for can we do it there. That kind of goes back to how this call was kicked off. More organizations are asking, what can't I move to the cloud instead of what can I move to the cloud? I'd say we're definitely in that boat. I find Amazon Workspaces very interesting. We've had several calls with Amazon about that. We've been trying them out. We have some use cases for which Workspaces would, I think, support us very well. And I think that's interesting too. So I don't know whether down the road we'll be taking advantage of those in any production way or not, but something definitely we're keeping an eye on. And I think that's it. So with that, I'll turn the call back over to Julian. Thank you much.
Well, thank you very much, Mike, and thank you to all our speakers. And now it's time to cover some of the questions that have been asked while the presentation's been going on. So that was excellent. Thank you very much, everybody. I think we've got a great recording here.
Cool.
So I'm going to stop the recording right now.